This question is asking which molecule is the most stable. Consider both chair conformations that can be formed. So what we need to do is draw out all those chair conformations. Okay, each of these molecules is a di-substituted molecule. They're all cyclohexane with 2 methyl groups. The difference is where the substitution occurs. We have 1,4 substitution, 1,3 substitution, and 1,2 substitution. So let's draw out all of the chair conformations and then assess which one's the most stable. Okay, so let's start with number 1. If we draw our 2 chairs, we're going to have, this is a 1,4 substituted case. We have a down methyl and an up methyl. Okay, so 2 equatorial methyls, that's looking pretty good for stability. Let's consider the chair conformation as well that is going to result after flip. After flip, we're going to have axial and axial. But the more stable conformation is the one that would predominate. So we're going to focus in on that one. Okay, second example, we have 1, 2, 3 substitution. We have an up methyl here and a down methyl at the 3. So 1 axial, 1 equatorial. When we draw our ring flip, this becomes equatorial and this becomes axial. So 1 axial, 1 equatorial. So that's not as stable as 1 because in molecule 1, we had 2 equatorial positions. Let's take a look at 3. In the 3, we have 1, 2, 3, 4 pattern. So we have an up and an up. So again, 1 axial, 1 equatorial. And when we draw the chair flip, whoops. Yeah, that was in the right direction. When we draw the chair flip, we have equatorial and axial. So 2 and 3 are pretty equivalent to each other. Let's take a look at 4. We have 1, 2 substitution here. And here we have both down. Again, an equatorial and an axial. And when we do the ring flip, same idea, down and down, but 1 equatorial, 1 axial. So if we're trying to define which one's the most stable, that's got to be molecule number 1. Because in molecule number 1, you have a conformation where both methyl groups can be equatorial. And in molecules 2, 3, and 4, that's not possible. 2, 3, and 4 all have 1 axial and 1 equatorial. So molecule 1 is going to be the most stable. And so our answer here is A.